Lesson 2 was a coding R script that you turned in. So I can show you what that looks like on Classroom. That way you know if you are looking at the right assignment. But what I'm going to be doing in this video is the bias detective lesson where we looked at dice. So it's this one here, lesson 2 R script, bias detective. And you should be turning that in for points. So in this video, I'm going to go over it. You can do it along with me, and then you can turn it in. I'll be going over all of it, so you'll be able to turn it in at the end of the video. So in class, we looked at these slides. I'm not going to go through every single one. I'm just going to go through the necessary ones to help us get through the assignment. So I reminded the class about probability and simulations and so on. So we're using simulations to estimate probability. I'm pausing on this slide to remind you that on a 6-sided die, there would be a probability of rolling any given number 1 out of 6. So the odds of rolling a 5 would be 1 out of 6 because there's 1 of each number and 6 total possibilities. As a percentage, that is 17%. So we would expect the odds of any of the numbers we roll to be about 17%. We did end up putting some things in our journal, so you can find these slides online if you need to spend more time on the actual journal part. I'm going to be focusing on the coding, so you can turn in the R script. So I'm just summarizing. We did this in class with actual dice. We rolled them physically. And so over time, we got through all of this physical dice part. We put some things in our journal, etc. And we ended up learning about the roll die function that we did in RStudio. So now I'm going to go ahead and move on over to RStudio and show you the code that you should turn in as an R script. Notice that my workspace is pretty much cleared out. I cleared my environment, so it's empty over here. I don't have any R scripts open, although I am going to make a new one and have that open. So you might want to clear some stuff out on yours. The first thing I'm going to do is click File, New File, and then R script. You are going to click this blue save icon, and we are going to name this lesson 2. And then you always want to put your name. So by Jordan Hager for me, of course, put your name. Your first line will always be your name again. This really helps with my grading process. And then your block, whatever that might be. So the first thing we're going to do in this lesson is we are going to do the roll die function a few times. And we're going to focus on 2 different die because we have 2. There's A and B. And so in this title, I'm going to just call this rolling die A. And then we're going to also have a section later for rolling die B. You can make that ahead of time if you want. You don't have to. All right. To roll this simulation die, the function is roll_die. In parentheses, we have to specify which die we want to roll because, like I said, there's more than one. So the first die we want to roll is die A. So you're going to have to put that in quotation marks. And then we want to specify next how many times we want to roll it. So for now, it doesn't really matter. Maybe we try just 10 times. But go ahead and run this. You can click the run button or you can simply hit Control Enter. But I rolled it 10 times and these are the results. So on the first roll, I got a 1. On the second roll, I got a 5. On the third roll, I got a 6. On the fourth roll, I got a 5 again, and so on. What I want you to do now is play around with the times equals and see if you can figure out what the maximum number of rolls is that you can do. So for example, if I did 100, this is the results of 100 rolls. The maximum number of rolls you can do in one round is 2,000. So here's all 10,000 or 2,000 rolls. All right, let's actually get this going. So go ahead and change this back to 10 for now. And what I want you to do is at the front, I want to store these 10 rolls. So I'm going to name this maybe just sample A, so that when it rolls the die 10 times, it's not going to show up in the console. It's going to actually save the answers. So we'll run that. And so you can see that nothing popped up down here, but in my environment over here, I have sample A now, which I just created. So if I wanted, I could view sample A. If I just type sample A here and click enter, it'll show me what is stored under sample A. So I got a 1, 6, 3, 3, 5, 4, and so on. What I'm going to do now is do the tally function for sample A. And all that's going to do is tell me like how many of each number I got. So I got 2 1s, 1 2, 3 3s, and so on. So what I might want to add in here is format equals percent, or proportion would work too. This way it tells me what fraction I got of a certain number rather than the count. So I got 20% ones, 10% twos, 30% threes, 20% fours, and so on. Go ahead and change this times to 50. I'm feeling like 10 still isn't enough, and we're going to run this entire section. So you can see now I got 18% ones, 20% twos, and I can even show you sample A if that helps this make a little bit more sense. So now that I reran this 50 times instead of 10, here's all the results. So of this entire list, 18% of them rolled a 1, 20% of my results were rolled as a 2, 16% were rolled as a 3, 16% were rolled as a 4, 14% of the time I rolled a 5, and then 16% of the time I rolled a 6. Remember earlier we said that the probability for any given number would be 1 out of 6, because there's 6 possibilities, right? So about 16.6, or if I rounded, 17% is the perfect number I'm looking for if it was a perfect world where everything was perfectly fair and it worked out, you know, according to the probability. All right, let's make a histogram real quick. So I can see the tally table, right, the percentages of each possible outcome, but I want to get a visual of this. So we're going to make a histogram of sample A. And I want you to actually make sure you have the NINT set to 6. Because there's 6 possible outcomes, I want there to be 6 bars, because that would make way more sense in this scenario. So now my histogram looks a lot better. And so you can see it does have a dip here, because again, what we're looking for is which die is biased or weighted or unfair or cheating. So one of our die is cheating and is going to roll on some numbers more than others because it's not fair. Right now, die A is looking a little wonky, because if it was perfectly fair, we would see a pretty even amount of on each bar, because the likelihood of rolling any of these numbers should be, you know, equal. Let's take a look at die B before we decide which one is unfair. So I'm just copying and pasting what I did for die A, but I'm going to change this to sample B. We're not going to roll die A anymore. We're going to roll die B. We're going to keep it as 50 times. So I'm going to just run this one for now. So here you can see I created sample B. It's the same process, but it's with a different dice. And then for tally, we're going to tally sample B. So you can see for sample B, here's my results. I got 20% ones, 14% twos, 18% threes, 24% fours, only 6% of sixes, which is kind of weird. And then let's make our histogram. Again, don't forget to change sample A to sample B. Here's my graph for sample B. Both of my graphs look bad. I'd say sample B so far is looking worse. But because they're both so wonky, I think I need to definitely increase the number of times we're doing this. So let's make it 2,000 in both. And I also want you to add a title to your histogram. So I'm going to do this one as die A for the title. Since I'm going to run all of this at once, I want it to be clear which histogram is which. This one will be die B. So I am going to run this entire section, like both chunks, all at once. I got an error here, so just be careful. Let's see what I did. I forgot the main equals on my title, so my bad. All right. So here's the graph for die B, and here's the graph for die A. Die A is looking much more even spread. It's still a little funky, like I'm still seeing, it's not perfectly even. Here's die B, it's even worse. Let's look at the tallies here to check everything, so we can see actual numbers instead of just the graph. So for sample A, it's looking like it's like 17% ones, 15%. They're all around that 16 to 18% range for die A. For die B, it's looking like it goes all the way as low as 14 and as high as 22. So that one's looking a little bit more all over the place. I still feel like it's not quite enough. I think we're getting closer. But here's the big thing I wanted to teach you in this lesson, and the part that I'll be kind of grading. I mean, everything we've done so far, I'm grading as well. But let's get more than 2,000, and I'm going to help show you how we can do that. Because remember, 2,000 is the maximum. Like if I tried to do 3,000, I would get an error, and it would say that it can't do more than 2,000. So we can only do 2,000, but I'm going to show you kind of a loophole or a workaround. So I want you to take this sample A, and you don't need to make a new section or anything. Just click enter and put another one under it until you have 4 in a row. So we have 4 of sample A's here. Now we don't want them to all be the named the same thing. So maybe we change this to A1, A2, A3, and A4. It doesn't really matter what you name them. Just make sure they're all different names. So like, once I run these, you'll see over here in my environment, they will pop up. So we have sample A1, A2, A3, and A4 now. Each one is 2,000. They're all different samples though. It's like I rolled my die 2,000 times and then started over and did it another 2,000 times and then started over and so on. So what we're gonna do is take these 4 samples and combine them into one. So I'm gonna make one large sample that's going to include all 4 of these. So 2,000 times 4 is 8,000. I'm expecting to see a new sample A with 8,000 rolls in there. So we're going to have sample A. And remember, the C function is used to combine. So I want to combine sample A1, which was 2,000 rolls, sample A2, which was another 2,000 rolls, sample A3 was another 2,000, and then finally sample A4 was another 2,000. So when I combine all of these, I should see my sample A. Notice it's still here, but it updated. Now I have 8,000 numbers in that list of results from rolling the dice. So now that we have a new sample A that's a lot larger of a sample set, we are going to tally it. Before I do that, I want to show you on this graph for die A, notice the y-axis only goes barely above 300. Since we're dealing with 8,000 dice rolls now, we should expect that y-axis to be a lot higher. So it's just a way to kind of make sure that everything processed. So let's run my tally. So you can see my tally down here. I'm really starting to see things start to level out. Everything is in that 16% to 17% range. Let's run the histogram and make sure that looks good. For my histogram, again, it's looking so much better. Before, here's the die A from before. It's a little bit more uneven, whereas now that I did 8,000 rolls, it's just getting more and more even. The more I do, the more even and symmetrical this would be. So die A is actually looking pretty fair. It's almost even in terms of how many times I got each number. Let's go ahead and do this same process, but for die B. So I'm going to change sample B to sample B1 because I want to have 8,000 rolls instead of 2,000. So we'll create sample B2, which would be 2,000 rolls. We'll do sample B3, which is another 2,000 rolls. And then finally sample B4, which will be another 2,000 rolls. And then to combine all these together, I'm going to use the C function so that I can combine these and have 8,000 rolls for die B. So we're going to combine sample B1, sample B2, B3, and B4. So I'm going to run each of these individually just to show you. We have sample B here. Right now, sample B is only 2,000 because we did that earlier. It should update when we're done. So now we have, when I run this, you'll see sample B1 pop up, sample B2, sample B3, sample B4, and then finally the new sample B should update. So now it says 8,000 instead. Okay, now that that's updated, let's rerun the tally. Now that we have 8,000 rolls, we can start to see a more clear difference here. Like most of them are around 15 or 16-ish%, except for this one on 3. So it seems more likely to land on a 3 than the other numbers. Let's make a visual for this though. So I'm going to run the histogram now that it's updated. And so you can see that in the histogram, it's a lot more clear than it was before, that this die is biased and it lands on 3 more often than any other number. Whereas for A, it was pretty even. If we look at die B from the beginning, here was the first time we did die B. I mean, it's really interesting because landing on a 3 actually wasn't even that common when we did it the first time. But it was simply because we didn't do it enough. We only rolled it, I think, 50 times in this one. And then when we did it 2,000 times, we started to see a more clear difference. It still wasn't super obvious. And then finally, when we did 8,000, we saw this super obvious bias here with landing on a 3. So it really takes a lot of samples to start identifying trends or bias or probability or things like that. So make sure that your work is organized. The other thing that I required everyone to do when we did this in class was to have comments. So I want you to have a comment here that says something like rolling die A 2,000 times or something like that. Right here, we need a comment explaining what that combine function did. So basically, you can think of these comments as like taking notes in a way. So right here, I'm going to say combining into one sample of 8,000, maybe, rolls. For the tally, maybe we say analyzing results for die A. And then maybe for the histogram, we say visualizing. We'll want to do the same thing on die B. And then on line 18 down here, we ended up combining, so we can say combining into sample of 8,000 rolls. On tally, we were analyzing die results for die B. And then for this last one, visualizing results for die B. All right, when you think you're ready, we can turn this in. I hope you agree that clearly die B is the one that's biased. So let's go ahead and download. I'm going to show you how to do that. If you need help, you're going to click on File in the top left and then Compile Report. When you get this pop-up, it should say PDF. If it doesn't, click the drop-down and change it. Click Compile again. And you should eventually get this pop-up PDF. What I love about this is that you can see not only all your code, but the results. So we can see the proportions here. We can see the graph where it's all pretty even for dye A. We have our proportions for dye B, and then the graph for dye B where we can clearly see that it lands on 3 way more often than the rest, which is not fair or bias.